The second application we are trying to do using a chi-square is to do the testing for this contingency table, right? So what does that mean for the contingency table? So in a simple, easy way to understand that is, in a table you have columns, right? And then you have rows, right? So that's a contingency table, right? So let's use some example here to understand how do we apply this chi-square. So let's see, we have this example here. So we ask 200 doctors and 200 nurses. We ask their opinion in terms of some new medical procedure or like a new medical device, right? To see if they like the new device or they like the old one, or there's no preference. So out of the 200 doctors, right, we got the feedback. 50, they like the new one, right? And then 120, they like the old one. 30, there's no preference. So that's the output coming from the 200 doctors. You see that here. And then for the nurse, similarly, we got the feedback. 100, they like the new one. 80, they like the old one, right? 20, no preference. So adding them together, 200. Similarly, 200 doctors, right? Here happen to be the same number, right? But not necessarily always to be the same number, right? It's depending how many people you asked, right? So we have the summation for each row here. We have a total. Also summation for each column here, everybody. So you see that how many people altogether like the new one? 150. How many people like the old one, right? 200. How many people like the no preference? 50. Everybody, if you add them together, right? So 150 plus 200 plus 50. Altogether, you got 400. So that's the total summation. Similarly, you added a summation of these two rows here, right? 200 plus 200 got 400. You see, you can verify your calculation right or not, right? So what are we trying to do here, right? We are trying to consider like those nurses, those doctors. We are trying to see, do they have same opinion on this medical device or not? From the statistics point of view, right? It's not that easy to compare everybody, people's opinion. Like how do you quantify them? They are different, right? Statistically speaking, it's a group of people. It's not like one person compared with another person. It's relatively easy, is that right? Now, it's a group of nurses and a group of doctors, right? Do they have the same opinion in terms of that medical device or not, right? So if they have, for example, very different opinion, right? We understand it better, right? They may, from the practical reality side, right? People may, especially for those device company, right? So they may realize why is that. Sometimes they want to do further study, right? So that's the question here we try to answer. How can we know that? Using statistics test, right? Do they have essentially same opinion or not? So that's the one we want to use chi-square. Everybody, chi-square distribution to do the test for that. So the same formula, everybody, same formula, the chi-square equal to the summation, the same formula we are using earlier, okay? Now, the only case here is the number of cases we are getting one more. You can understand that way, okay? So what's happening here is we have, you see this table, is that right? Nurse, doctors. That's the output from the data. So what do we call, this is the observed data, right? So we have this observed OI, right? So it's O1, O2, O3, O4, O5, O6, everybody, right? The next question is, how do we find out the expected one, right? Remember previously, in the previous example, we have 100 people. We want to see, do they have an equal preference or not? So the expected case is what? 100 divided by 5 groups. But right now, we cannot do that. We cannot have 100 or 400 divided by 6. We cannot do that, right? They are not, we are not saying all those 6 groups, they are equal. Everybody, we are not saying that, right? So that's tricky here. So how do we get this expected number, E1, E2, E3, and so on? Everybody, pay attention if you care about finance. So how do we calculate, for example, E1, right? This position here, corresponding for O1, right? Everybody? So how do we calculate this position here? It's like the first row, first column, right? The E, we know O1 is 100. How do we calculate E1? Everybody, pay attention to the rest 1 to 2 minutes. How do we calculate E1, expected number for this position? So what we are going to do is using this corresponding summation from this row, right? This number here, corresponding row 200, right? Summation, multiply the corresponding summation from the column 150. So 200 multiply 150 divided by the total of 400. So one more time, everybody, let me try to draw something here. You understand what I'm talking about, right? So what we are trying to do, we are trying to calculate, right? Trying to calculate what's the let me use some number here, right? For this position, right? We know that's the O1, 100, right? So because in the formula, we have like E1, expected number, right? How do we calculate this E1? Everybody, we are going to use this position corresponding row summation 200 multiply the corresponding column summation 150 divided by total of 400. Okay, so so that's our first case here to calculate what's the expected number of this E1. So let me erase that. Let me go back to this case here. You check, is that 200, the summation of a row, everybody? 200, let me see. 200, the summation of the row, right? And then summation of the total, 150 divided by 400. You see that here. You see, that's 75, right? Similarly, we can do the this position. Everybody, how can we calculate the expected number for this position, right? So how can we do that? Let me see. Right? How can we calculate that? Right? So we are going to use the summation of this row 200, multiply the summation of a total 200 divided by 400 total. That number. Everybody follow me? So that's the way. If you want to see, so that's 200 multiply another 200 divided by 400. That's the for this one here. Is that 200 multiplied by 200 divided by 400. Follow me? So we are going to do that for each one here, right? To calculate, to do the calculation. For each of these expected number, everybody, expected number. So we have E1 here is 75, E2, 100, E3, 25, E4, E5, E6. Everybody? So now we have the corresponding observed, right? Observed, where is that? At this number here, 100, right? Minus the expected. So 100 minus 75, that's what we have here, right? So OI minus EI, remember the formula, right? And then square. So 100 minus 75, and then square. So let's go back to our calculation here. You see that? So it's 100 minus 75 square divided by 75. That's E1. E2, 80 minus 100 square bracket, right? Divided by 100, right? And similarly, term by term, adding them together, how many terms? 6 terms. So at the end, we got the answer 26.67. That's what we call chi-square statistics. Everybody? That the data tells us, right? What's the data from the sample, right? Chi-square 26.67. Now, step number 2, how do we find out the critical value, right? The critical value, remember, is coming from a table, right? So let's open the critical value table, chi-square, right? Critical value table. What's the alpha? Alpha is 5%, right? Remember the 5%, this column here, right? So what's the degree of freedom, everybody? It's number of groups minus 1. So how many groups here, everybody? You see that we have 6 groups minus 1. So that's about to be 5, right? Is that one here? So it's 11.070, right? So we can say our critical value, oh, that's not right, everybody. I am so happy. I was so excited to jump into the conclusion. We are using a different formula here for the contingency table here. Everybody, forgive me. I was thinking about the same formula for the degree of freedom n minus 1, right? So this case here, contingency table, we have a different concept. Contingency table, we have number of rows, we have number of columns. So this column and row give us 2-dimensional. It's different from the previous one when we say 5 groups, the number of degree of freedom 5. 5 minus 1. Then we got degree of freedom 4, right? 6 here, but we cannot say 6 minus 1. Why? We have 2 dimension. We have a nurse, doctors, those 2 groups, right? So the formula we are using is going to be very tricky here, everybody. That's the last complex formula for our class here. It's going to be number of rows minus 1 and the number of column minus 1. Those 2 numbers multiply together. So what does that mean? So we have number of rows. How many number of rows, everybody? This table here, how many number of rows? Be careful here. The last row is the row we add by ourselves. So original data, we only have 2 rows. So the number of rows, 2, right? Number of columns, 3. The last columns is the column we add by ourselves. That's not included. So number of rows, 3 minus 1, we got 2. So we got the degree of freedom, everybody. 2 minus 1, 2 rows minus 1. So we got 1. 3 minus 1, we got a 2. Multiply them together, we got 2. Degree of freedom, 2. So now we come back to this degree of freedom. So which is the 5%, give us degree of freedom 2. Give us the value 5.991. Everybody, that is our critical value, 5.991. Then we can draw this bell-shaped form, remember, right? Let me draw that so we know what's happening here, right? So it's not a symmetric, right? It's not that easy to draw that. Like that, right? Trying my best to draw that, right? So our critical value right now is, say, somewhere here, 5.991, right? 5.991, that's our critical value. Where is our data? Our data from the calculation is 26.67. It's like somewhere here, 26.67, right? 26.67. So we know the data from the sample is further away from the center. What's the center? Remember, the center is what? H0. Yeah, is it right? So center is H0. What does that mean? That means the center is not right because the data is further away, right? 26 is further away from the center. So we are going to reject H0. We are going to accept H1, right? Why do we care about H1? H1 is the preference. So we are asking those doctors, those nurses, right? Do they have essentially the same opinion or different opinion? Now we know they have significant different opinion on that new medical device or like a procedure. So that's the conclusion we are getting for this example here. Everybody? So make sure you know how to apply this chi-square calculation here to make the conclusion, right? Now, also some notes here. Number one, the data, the sample we are getting, always everybody has to be random sample. We cannot have, for example, doctors, nurse, right? If we are trying to see is doctors and nurse from the whole state, right? You want to, cover every single hospital if possible, right? Not a particular Kaiser only, like or like Hog only, like those cases, right? So random, if you want to really study, is the overall, right? Number two, the same we mentioned previously, each expected outcome should be greater or equal than 5. Everybody? So what does that mean? That means when we calculate this number here, expected number here, right? We got 75 for E1, 100 E2, 25 E3, right? Each of those expected numbers should be greater or equal than 5, right? So which is satisfied in our case here. But just in case if it's less than 5, then we cannot use this chi-square formula to do the hypothesis testing. So in statistics, if you study more, we have another way to do that. So which is the much more complex formula. So that's for the second application. Everybody using a chi-square to test the contingency table. So in a way that we want to see any, like the doctors and nurse, right? Do they have a significant different opinion from each other or not, right? So that's the for this application here.